Okay, how do you do this problem? This problem is an interesting problem, and it teaches a really important lesson on how to do research. The problem is they give you these two polynomials, and they say which of the following polynomials, the choices there, are divisible by 2x plus 3. So the first thing your brain does, it's a polynomial divisible by 2x minus 3, and it wants to be completely divisible. So the first thing that comes to mind, if it's completely divisible, that means the remainder is 0. So immediately you say, oh, maybe this is a remainder problem, because if you're able to make all these different functions and you put in x equals negative 3 over 2 into these different functions, then f of negative 3 over 2 better be equal 0. And that's one way to do it. The problem with doing it this way is it'll take forever. I mean, it'll literally take forever to multiply 3 times f of x plus 2 times g of x and then plug in negative 3 halves and do the math and calculate 0. That'll take literally forever. So you say to yourself, that can't possibly be. By the way, this is the question that you skip. And you come back to at the end. I mean, if you have 20 minutes, you can do it this way. But you say to yourself, there's got to be a better way. So what do? First of all, you stare at this thing and you use that concept called manipulation of polynomials. By looking at these two polynomials, you have to notice that you could factor f of x. Okay? So f of x is equal to 2x times, x squared plus 3x plus 2. OMG, look at that. Or this is equal to 2x of 2x times g of x equals f of x. Now, your intuition tells you that if you're not going to do it the long way, because there's really no time, this thing has got to be used. Somehow you've got to use it. Now the question is, how do you use that? Okay, so now you go back to the question, which of the following polynomials is divisible by 2x plus 3? So first of all, you get a little confused. What do you mean, polynomial is divisible? This looks really hard, right? I mean, what does this all mean? So then you ask yourself, what does it mean to be divisible? What does it mean to be divisible? And of course, with polynomial division, who knows what it means because it's so weird and complicated, right? So let's go back to basics. This is a really important thing we talked about. You want to take the simplest example and learn from it. So let's talk about 10 divided by 2. So now we're asking, what does this mean that 10 is divisible by 2? 10 is divisible by 2 means that the answer, which happens to be 5, is a number. There's no remainder, right? Is a number. 10 divisible by 2 is a number. So now let's translate this really simple idea, this concept that we brought out because everybody clearly understands what this means, right? Let's apply this to this problem. Let's just see where it goes. What does this mean? This means that the following polynomials, which are these three choices, right? These means the answers divisible by 2x minus 3 better equal a number. Better equal a number. If that's the case, if you get one of these answers and you divide by 2x minus 3, you better equal a number, right? So let's say that n times 2x minus 3 is equal to one of these answers. Right? Right. N times 2x minus 3 is equal to one of these answers. Okay? So now, this is the point where you have to just play. And this is the part that sort of deals with the concepts of research. First of all, you're getting somewhere. You're a little bit closer to the understanding as to what's going on. Now it's time to play around. Okay, so let's see what that would look like. Let's have some fun with this. Let's play with this. Let's do some research. N times 2x minus 3 has to equal an answer. So let's do f of x. Do you see where we're going? Do you see where we're going? Do you get it yet? Do you get where we're going? Right now it should start to become a little clear. Hey, something's happening here. This has got to be true. Okay, so now look, we have a relationship that relates f of x and g of x here, right? So let's just see what happens. Again, we're doing some research. We're just doing some research here. F of x is 2 of g of x. So look, 2 of x of g of x plus g of x. Okay? Now, interesting, right? Haha. Do you see where we're going? 2 of x, g of x plus g of x. Now you factor. Factoring is one of those things that's in the pink thing, you know, the manipulation of stuff. This is 2x plus 1 times g of x. Right? So this equals n 2x minus 3. Now, it's interesting. It's really too bad that this isn't 2x minus 3. Because if this thing here was 2x minus 3, then everything would be factorable, right? That would be amazing, right? So you're hoping, maybe one of these does work out like this. So that we did the first one, right? So let's try the second choice. F of x plus 3g of x. Okay? So f of x is 2x g of x plus 3g of x, 3g of x. So let's do the same factoring thing, right? So let's take out the g of x. So we get 2x plus 3, OMG, g of x equals n times, it's a plus, right? I made a mistake. I made a mistake here, right? It's 2x plus 3, right? Okay. 2x plus 3, n times 2x plus 3. Oh my God. Look at this relationship. The answer, this is choice B, is n times 2x plus 3. Oh my God. You divide by 2x plus 3, obviously, right? 2x plus 3, 2x plus 3, and they're factorable. You get an n. So, it's choice B. Now, you could go back because, you know, your confidence has been completely shot. You can try this one, and you can try this one. You know, like, we could do those. You might as well. You know, we were not going to do them in the video, but, you know, 2f of x plus 3g of x, and then f of x is 2g of x. So what? That's 6x. Something like that. G of x plus whatever, 3g of x. So it's 6x plus 3, right? And that doesn't work because it's not 2x plus 3. Anyway, wow. Wow, wow, wow. But what was the key? You know what the key was? The key was this. The key was saying, I don't really get this problem. I have no idea what's going on. Let me try to understand what division really means. This was the key to the problem. Going back to a basic, to understand what a division means. It means that you have no remainder. It means you have an n. By setting up an n, after we do this, we substitute the 10 are these different answers that are here. The 2x plus 3 they give you, and the n we have no idea. Who cares what the n is, right? We don't care what the n is. So, wow, right? Wow, wow, wow. So the idea is to make this and then just start playing with it. Just see where it goes. See where the problems go. The thing is, in order to do it this way, obviously you need time. So this is where doing the other problems, you know, efficiently comes in. This way you buy yourself whatever, like 5 minutes, 6 minutes, maybe you'll figure it out, you know. There's also possibility and probability that, you know, they have to have one question to separate the people to get the 780 to the 800. If they look at it from their point of view, right, if they put every single question on that everyone is getting right, all the incredibly smart Caltech kids are going to get an 800. No one's going to get, you know, they're all going to get 700s. They have to put a problem in that really, really the, you know, the best of the best of the best of the best they're going to get. You're shooting not for an 800, you're shooting for a 780, whatever, 770, something in this range. So you can afford a question like this to get wrong. Wouldn't necessarily kill yourself. You're never going to get a question like this directly, but you are going to get the idea of using a simple thing when you don't understand what's going on to really get what's going on in the problem, and then just start playing with it. And this is what you do. This is how you do research. Okay, hope that helps. We got to learn from this problem. We got to pick out as much conceptual stuff as we can on how to do other problems. Okay, that's it. Thank you.